The outriggers I made are out of a windsurfer, a polyethylene one that I got off Craigslist for like 20 bucks. I cut it in half. Well, actually I made two cuts, so the bottom and top portion of what I cut off I could use to cover my cuts. I used this polyethylene welding device shown here to weld the pieces back together. Before I did that, I sunk in a piece of 2x4 so I could screw in these collar pieces. There are more collar pieces that go across the boat. I screwed them in with a clamp and then epoxied them into place so there's no lateral movement. I call these collar pieces because they slip over top of this crossbar that goes through those collar pieces and then is bolted into place. This is one of two crossbars, and I've marked them so that way I know that my bolt holes will always line up. Here's the other crossbar, the forward one. It goes into place and then again is bolted in. It is marked so that way I know all my bolt holes will line up. Next goes on one of the outriggers. It has those collars that slip right over top of that crossbar, and then it is also bolted into place. Next goes on the other outrigger. Again, each one of these is half of a windsurfer. This is the final product as far as the outriggers are concerned. It makes for a very stable craft. If you just want it for your canoe, it certainly is something that you could fish off of. You can stand up, you can walk around in it. So here's my design to hold the front mast. Down at the bottom there, that's a small paint can that's filled with thin set and has a collar piece in it, and is then epoxied to the bottom of the canoe. This mast base is a piece of 1.25" electrical conduit, and it slides right in. Next I have a little piece of collar that goes on, and then this is the mast for the windsurfer. I cut a hole in it in the bottom of it, 1.25" to slide right over top of that. This is the bottom of the main mast. I actually just bolted the piece of wood at the bottom and bolted it to the bottom of the canoe. To cover my drill holes and to cover the bolts, I actually did a fiberglass patch over those at the bottom so that way you don't get any water in your canoe. The mast base for this one is actually 1.5" electrical conduit, and the reason I use that is so that way I could slide the other one inside of it. All my pieces of conduit are either 1", 1.25", or 1.5", and they all fit nicely inside of each other. I tried to keep the rudder design pretty simple. It's a piece of PVC that's been fiberglassed to the side of the canoe, and then another piece sits inside of it. This is the rudder itself. It's a piece of PVC, slightly smaller, and it slides right inside. I have a piece of sheet metal on it as the actual blade of the rudder. In the video right now, that's a piece of aluminum, but I have since switched that out to a piece of steel because I found the aluminum was a little bit flimsy. Once that's in place, I can go ahead and attach the tiller to it, and that should give me the ability to turn. Right now I'm attaching the main halyard, which controls lifting the mainsail. And now for the main sheet, which controls how far away the mainsail is allowed out. I believe this is technically a schooner because there's two masts and the main mast is a little bit longer or taller than the front mast. I'm not sure what the front sail on a schooner is called, so I'm used to a sloop, so let's call it a jib. So here are my two jib sheets that go to either side. And now I'm going to attach another rope. It goes around the bottom of this jib, and I'm essentially making a roller furling. The point of this is that if the wind was ever to get too large or too strong for me, I could always pull on that rope and it'll roll up that front sail and put it away. Here's the roller furling in action. Just have to release the jib sheets, pull on that red rope, and there it goes. So here's the cockpit and the hardware I'm using. The hardware here is actually the most expensive part of the boat. If you buy it at the actual store, it gets pretty expensive quickly. Lee boards is one of the most important things to design. Without it, you can't sail into the wind. I designed something that I could run aground and it wouldn't be destroyed. It would actually just pivot upwards. Also, then I also needed to be able to pivot downwards and not necessarily lock into place, but have a maximum amount it could pivot. So that's why I have two threaded rods that go straight across. One goes through the eye hole so it's able to pivot. To make it engage into place, I have this rope. I tie it to the back threaded rod, and I can pull on that rope, and it engages the lee boards into the water.